Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, we will continue with our lecture with linear combinations, spanning set, and linear independence. Okay, these three are quite similar to each other, so you have to be careful to differentiate all of these three. Okay, we start with the linear combination. Linear combination means you can combine the vector into another vector. U vector. Okay, a vector V is a linear combination of the vector in S. S could be in a vector form, or maybe in a metric 2 by 2, or metric 3 by 3. I think up to metric 3 by 3 for our level. And then for polynomial degree 2 or 3, or polynomial degree. Okay, so how do we combine this? Is you are given a few vector, so you can combine by using the addition vector. You add this all to vector to become another vector. So this vector is given. Okay, the V here is given. Your V here is given. Okay, let's say we go to question number 1. Okay, show that x vector x 5 negative 3 is a combination of u and v. Okay, this is an example of a vector R2. Okay, you have two components here. Let's say we go to do number 1. Okay, just follow this one. So you get 5 negative 13 C1. C1 is the scalar. If you want to use another as a scalar, like say K, you can also use K, but normally for scalar we can use C. Okay, for negative 3 plus C2 3 7. Okay, then you expand this. Plus 3C 7. Okay, then 5 is equal to 4C1 plus 3C2. Okay, and then negative 13 is equal to negative 3C1 plus 7C2. If let's say this is the first component, then first component plus another first component. Okay, so you will get the first one. Okay. And then let's say negative 13, so this is the second component, so you get the second equation. So if you get these two equations, then you have to solve. How do you going to solve the system linear equation? Back to our lesson. You can solve it by system by Gauss-Jordan, whatever method that you have learned. We have learned 3 methods so far, but normally because we do not know it is type of the solution, means that we do not know is it infinitely many solution, unique or no solution, then normally we will use the ERO. And I know that all of you like ERO so much. Okay, so this is the first equation. You have C1, C2, 5 negative 13. So this is negative 3, 7. Okay, so negative 3, 7, 5 negative 13. So row 1 divide by 4. So you get 1 over 4, 3 over 4, 5 over 4. I think instead of divide by 4, we just minus row 1 with row 2. Much more simpler, right? What else we have? The fraction here. Okay, so just row 1 is row 1 plus row 2. So 1, okay, negative 4, and then 5 minus 13, okay, negative 8, negative 3, 7, negative 13. Okay, and then row 2 is row 2, this is negative, so plus 3 row 1, so that's 0. 7 minus 12, you get negative 5. Negative 13 minus minus plus 8 is negative 5. 1, negative 4, negative 8. Okay, so row 2 is row 2 divided by negative 5. 1, negative 4. Okay, so this one is, sorry, divided by negative 5 is 1. 1, 1. Have 1, 1, negative 8. Okay, so your equation becomes C2 equal to 1. So when C2 is equal to 1, is C2 equal to 1? So C1 is negative 8 plus 4C. So negative 8 plus 4, 4 is negative 4. So C1 is negative 4 and C2 is 1. Okay, go back to your question. Go back, substitute your answer here and show that it is a combination of these two vectors. So you can answer C1 is negative 4, 4 negative 3 plus 1, 3, 7 is equal to 5 negative 3. So you can do this equation. C1 exists, C2 exists. So 5 negative 3 negative 13 is a linear combination of this and this with a scalar of negative 4 and 1. So okay, try to solve question number 2. Okay, show that it is not a linear combination. So how do you know that it is not a linear combination? You know it is not a linear combination if you cannot find C1 and C2. Try to solve for 2. Question number 2.